All right, you looked at the last video and you said, that last video was a great introduction video, but I want a video that's going to let me do some problems. I want to do more math, Jason. Well, this video is for you. Okay, we're going to start simplifying some trig expressions. But before we do that, we need to recall some very important things. And you might not even make it through this whole video. You might look at these recall things and say, okay, I need to study that more because these are really important. If you cannot do these things that I'm about to tell you, this whole chapter is going to be a nightmare. So it's worth going back and reviewing. And there's no problem if you've forgotten it or if you're not comfortable with some of this stuff. Just make sure to go back and review. It will be very well worth your time. Let me know if you have questions about that. All right, so the first thing is just factoring in general. Factoring trinomials, factoring with the AC method. And we can't review this all of this in this video. I have other resources if you want. Trinomials, maybe the AC method, factoring by grouping, etc. These are all techniques that we're going to be using that are going to come into play both in 9.1 and 9.5. So make sure you're remembering those. And then there's a couple of factoring formulas that we can review. So difference of squares, a squared minus b squared. That's a minus b times a plus b. This is another one that's going to come up a lot. And perfect squares. So a squared plus 2ab plus b squared. This is a perfect square, a plus b squared. And then again, you can also change this to a minus. And if you change that to a minus, this one turns into a minus as well. It looks like I'm underlining. That's a minus sign. All right. So, last thing, remember what this means. This is just shorthand for the sine of x squared. All right, it's just shorthand. We don't like parentheses. Well, I love parentheses, but most people don't like writing more than they have to. So that's what's going on here. So these are the main things that you have to have in your head as we're, oh, that makes a really loud sound when you tap your head and you're bald. Not that you can hear it. You're not inside of my head. So these are the main things that you should review before we really get into this video. So hopefully you've reviewed them. Otherwise, again, please let me know and I'll give you some resources. Let's do an example. Example 2, factor the following. And I said we can't review factoring, but don't worry. This is spicy review. This is factoring trig. 2 cosine squared of theta plus cosine of theta minus 1. Now, most people are kind of weak at factoring in the first place and definitely struggle with factoring trig. So if you want, you can use a substitution to make our lives easier. Okay, so we can that's what we're going to show you how to do. Can use a substitution. And what we're going to do is let's just say x is going to be the cosine of theta. Because this is a quadratic, but it's like a trigonometric quadratic. It doesn't look like a quadratic maybe, but it is. So this right here is x squared. And this right here is x. So to factor it, let's write this as 2x squared plus 1x minus 1. And now it becomes much easier to factor. Now, it still might be a struggle for you. But at least it's a factoring struggle, not a trig struggle. It's always important in math to identify what the actual issue is. This problem, the issue is not trig. The issue is factoring, all right? Okay, so there are a couple of ways of doing this. One way of doing this is the AC method. That's a method I love. There's also the guess and check method. But I'm going to use the AC method because I know if I use the guess and check method on a video, I'm going to make a mistake. All right, so AC method says we look for two numbers that multiply to a times c. A times c here is -1. I don't have time to review the full method, but I'll try to talk my way through it a little bit. Two numbers that multiply to -2, a times c, that add to the middle coefficient of +1. And our answers are going to be +2 and -1. We split up this middle term using those coefficients. So we get 2x squared plus 2x minus 1x minus 1. So notice that the blue thing just got split up into two blue things. Okay, 2x minus 1x is 1x like we had before. And now we factor by grouping. In the first group, we can take out a 2x. We're left with x plus 1. In the second group, we can factor out a -1, and we're left with x plus 1. Every time we factor by grouping, the things in the parentheses should be the same. And what we're going to do is we're now going to factor that common factor. They both have an x plus 1. We're going to take that x plus 1 out of both of them. And we're going to be left with 2x is what's left over from the first term. Minus 1 is what's left over from the second term. And we've successfully factored. The AC method takes longer, but it's usually a pretty good solid method. All that's left to do, x is cosine theta. Let's substitute it right back in. This is going to be the cosine of theta plus 1 times 2 cosine of theta minus 1. And that's how we do this problem. Now, a really good way of checking your answer here is, you guessed it, foiling it out and seeing that you got the same thing here. So you could go off to the side, right, and say, you can check by foiling. But we're not going to do that here. All right, but you can do it. Let's do part B. Part B is 4 cosine squared of theta minus 1. And again, you can use an optional substitution. You don't have to do this red step, but it can make things easier. This becomes 4x squared minus 1. This is the difference of squares, right? This blue thing is 2x squared. This green thing, right, that's minus 1 squared. So that's a squared minus b squared. And we can use that difference of squares formula. So this becomes a, and a is 2x, minus b, which is 1, times a plus b. And as the final step, x is cosine of theta. So we can get 2 cosine of theta minus 1, 2 cosine of theta plus 1, and again, we can check our answer with foiling. All right, now let's do some examples. We're going to use some identities, that big page of identities from right here, and simplify some stuff. And that brings us to example 3. Example 3 says simplify using identities. And this is where things get really fun. They'll get even more fun in the next video, and then more fun in the next video. It's just like an increasing function over time where the function models the amount of fun you have. We got an increasing function, positive derivative. We're not talking about derivatives in this class, but if anyone's taking calculus, that'll come up. All right, part 1, part A, cosecant squared of theta minus cotangent squared of theta. And there's a couple of ways that you can simplify this. First off, we could factor this if we wanted to. I wouldn't recommend it. Factoring is not really going to help us simplify, but we're trying to get rid of things. So anything that can relate cosecant and cotangent can help us. Any identities that relate cosecant and cotangent could help us. Or sometimes we just put everything in terms of sines and cosines. All right, but we need to combine these terms. So there's a bunch of ways of approaching this problem. So the quickest way of approaching this problem is to say, look at this Pythagorean identity. This Pythagorean identity relates cosecant and cotangent. So I'm going to just show you both two different ways, right? What's that identity? Find an identity relating these two terms, cosecant squared and cotangent squared. That's one way of doing it, if you can find one. So 1 plus cotangent squared is cosecant squared. So what we can do is we can substitute. This is equal to cosecant squared. So you can substitute that, right? Cosecant squared is 1 plus cotangent squared. And you still have the minus cotangent squared as before, right? This blue thing is the same as that blue thing because of the identity. I forgot my equal sign. Oh, well, this is really nice after this, right? We have a plus cotangent squared. We have a minus cotangent squared. That cancels, and we're just left with 1. So that's one way of approaching this problem. I think it's a little hard to see this, but if you see this, great. Use this method. This is a great method. Another method that you can use is put everything in terms of sines and cosines. This is usually a more straightforward method, but it's a little messier and it might take a little time. All right. But if we do it that, cosecant, maybe you forgot what cosecant is. Cosecant is the reciprocal of sine. So sine is 1 over cosecant and vice versa. This becomes 1 over sine squared of theta minus cotangent. What was cotangent? Cotangent is cosine over sine, and we have cotangent squared. So it becomes cosine squared of theta over sine squared of theta. And so it's not maybe immediately apparent what's going on here, but we can simplify by combining these fractions. They have the same denominator. You can only add or subtract fractions if you have the same denominator. Well, they do. So this becomes 1 minus cosine squared of theta divided by sine squared of theta, and we'll use an identity. This is an easier to see Pythagorean identity, but it's still a Pythagorean identity. Cosine squared of theta plus sine squared of theta equals 1. Right? Cosine squared of theta plus sine squared of theta equals 1. So again, we can substitute. If you want, you can solve for cosine squared here, or you can say this red underline is the same as this red underline. Cosine squared plus sine squared equals 1, and we have 1. So substitute that in. Cosine squared of theta minus sine squared of, plus sine squared of theta. And we still have the cosine squared of theta from before, and we still have the sine squared of theta in the denominator. And again, what's underlined in red is the same as what's underlined in red. All of these underlined in red things are the same. And just like before, we get cancellation. Cosine squared minus cosine squared is equal to 0. We're left with sine squared of theta over sine squared of theta. Oh, this is nice. And again, we get cancellation. It cancels to uno, which for those of you who do not understand Spanish means 1. So 2 different ways. There are more ways. There are a bunch of different ways of simplifying, but these are the 2 main ways for this problem. And that's something that a lot of people hate, but a lot of people love too about this section. There's no straightforward way of doing it. It's problem solving. You have these tools. The tools are your identities. These are all of our tools. But you're not told which one to use. And the more and more of these problems you do, the more you'll kind of figure out a problem solving strategy for them. All right. Let's do part B. Cosine of theta divided by 1 plus sine of theta times 1 minus sine of theta divided by 1 minus sine of theta. So you're supposed to simplify this. And there's a little trap. There's a trap that has been set for you. The trap is, and don't write this down, you might say, let's cancel this, it's simplified. But in this case, this is actually a common trick that you're not expected to know at this point, which is why I'm showing it to you. This is a common trick for simplifying in this chapter. So let's watch and see what happens, shall we? So if we watch, we're going to need to distribute. So I'm going to add some parentheses. On the top, we distribute that cosine, and we get the cosine of theta minus sine of theta cosine of theta. So it doesn't look good yet, but it's going to get better. Also, I just remembered that it would have been easier if we didn't distribute the top, but you might not know that. So let's distribute the top. And the bottom is the difference of squares formula. 1 plus sine, 1 minus sine. We could FOIL the whole thing out or use the shortcut. Get 1 minus sine squared of theta. And before you get upset and say, Jason, this is not looking good, don't worry. We're going to use, again, one of our Pythagorean identities. Sine squared of theta plus cosine squared of theta equals 1. And one way of doing this, you can move this around if you want. What if we subtract sine squared of theta from both sides? Then we get that cosine squared of theta is 1 minus sine squared of theta. There's a bunch of different ways that we can rearrange the Pythagorean identity. Because now this red is the same as this red. And our denominator is now just cosine squared of theta. So we'd like, again, all these red underlines are the same thing. We'd like to simplify. We'd like to cancel. But you can't cancel fractions unless things are factored. So we're going to factor the numerator, which is exactly undoing this step. So we shouldn't have distributed, but you might not know that. And that's what happens in this section. You don't always know the right answer. So sometimes you play with something and then you have to undo what you did and you just try to move things around, try to see things from different perspectives, try to see things from different angles, move things until something kind of falls into place. So we're going to factor the top and get cosine of theta times 1 minus sine of theta. Because now it's fully factored and we can start canceling fractions. We have a cosine of theta up here that's canceling with one of the cosine of thetas in the bottom. Because remember, cosine squared of theta, that's cosine of theta times cosine of theta. So we have one of these cancel with the one on the top. And now, what are we left with? We're left with 1 minus sine of theta divided by cosine of theta. All right, I tricked you again. So it doesn't look a lot better, but it's useful. This is a useful trick. This is actually what we're going to be ending with. I know a lot of you are going to be really unhappy with this. So this isn't really a simplifying problem so much as like me showing you a trick. I should have rephrased it and made it look more like just using the trick. But here's why this is useful. Here's why this is a better form. It doesn't look a lot better than what we started with, right? But it's a better form because there's only one thing in the denominator now. So this form is very useful when our denominator is sine and we want our denominator to be cosine. All right, so there's only one thing in the denominator and we've switched it from sine to cosine. So this will come into play later on. It's a good thing to be aware of. We'll reference this probably, literally in the same video, which is going to be a long video. Let's do another problem. Example 4. Simplify the first trig expression by writing it in terms of the second. Part A. I want you to simplify cosine of x divided by 1 plus sine of x plus tangent of x. I want you to simplify that by putting everything in terms of cosine. So this is what it means, right? Simplify the first is the red thing, by putting it in terms of the second, that's the blue thing. That's what the question's trying to phrase it as. So this first thing should look a little familiar. We just did it, okay? So the idea here, right, is we want to put things in terms of cosine. So tangent, right, this first thing, let's just leave it alone for now. We can't really do much with the first thing. But tangent, we can write as sine over cosine. So we'd like to find a common denominator. And one of the ways of finding a common denominator here would be to do exactly what we did in the last example. All right. And so we're going to take a little shortcut, right? This green thing, right? This green thing is equal to 1 minus sine over cosine. We did that in example 3b. We don't have to do it again because we literally just did it. So if we write it like this, 1 minus sine x over cosine of x, now we can simplify this much more easily because now our denominators are the same. 1 minus sine, we can add positive sign to that and they'll cancel. Whenever you have two fractions with the same denominator, you can combine the numerators. And we're just left with 1 over cosine of x, which is secant of x. And again, this is a trick that we're going to use. This green step is a trick that we're going to use. But it's not the only way of doing this. Like if you kind of wanted to do this a different way, you could just get a common denominator by multiplying this by 1 plus sine of x over 1 plus sine of x and so on. Here, let me kind of show the alternate method. I think it works. I've actually literally never done it before. What could go wrong? But if you wanted a common denominator the other way, you'd look at the first fraction and say, okay, in order to get a common denominator, we have to multiply by cosine of x over cosine of x. And you'd look at the second fraction and say, okay, in order to get a common denominator, we have to multiply by 1 plus sine of x over 1 plus sine of x. And then what you'd get is cosine squared of x divided by cosine of x times 1 plus sine of x plus sine of x times 1 plus sine of x. There's a lot of good algebra in this section. We scroll down so you can see. And now we have a common denominator. We can add things together. Cosine squared of x is the same as 1 minus sine squared of x. Let's distribute this guy as well. We'll get sine of x plus sine squared of x. The bottom is still the same. In general, it's a good idea to leave your denominators factored. And then, of course, minus sine of x. Oh, this cancels. Great. And when it cancels, what are we left with? 1 plus sine of x over cosine of x times 1 plus sine of x. I'm still blocking it. Oh, and the 1 plus sine of x is cancel. We're left with 1 over cosine, which is secant of x, just like before. So you don't have to use this green step if you don't want to, but we do have to combine these fractions. You can combine these fractions by using that little trick to get this denominator into cosines, or you can combine the fractions in a messier way. All right. Algebra, adding and subtracting fractions is big here. It's not probably so much about the trig, maybe the identities a little bit. The algebra is a big thing here. Let me know if you have questions about that. Final example of this long video, going to be tangent of x in terms of secant of x. This is just a problem from the book. It's written really weirdly. It just wants you to put tangent of x in terms of secant of x. It doesn't really get simplified, but it is what the book asks you to do. So I want to show it to you. So tangent, that's sine of x over cosine of x. We have a identity that says that, quotient identity. And we want to put things in terms of secant, right? So what's secant? Secant is 1 over cosine of x. So let's write this like that. This is sine of x times 1 over cosine of x. Okay, and then again, this 1 over cosine of x is the same as secant of x. So again, in this example, I really don't think this is any simpler, but this is what it's asking you to do. And it's one of these examples where even if you're not doing anything good, it's like lifting weights, right? Lifting weights is not being productive. The only point of lifting weights is to strengthen your muscles. Changing this into this is not productive. The book is just asking you to do it in the homework to work on your mathematical muscles. All right. So you're getting your trig brain is getting ripped. All right. You can impress everyone with your summer trig bod. That's the end of the video. I'm going to leave you guys with that.